Hi. In this problem, we are going to look at a functions question where we are defining an odd function on real numbers. Fx is an odd function on R, and f of x is specified as x square for x positive, for x greater than equal to 0. Now, the question says that suppose for any x belonging to this interval, a to a plus 2 enclosed, f of x plus a is greater than equal to twice of f of x. Then find the range of a. Okay. So when we look at this problem, there is a little bit of a contradiction in the first statement. It says f of x is an odd function on R, while f of x is defined as x squared for x greater than equal to 0. But x squared is an even function. The thing is, this x squared f of x is defined only for x positive. So we have to use the x squared definition and try to come up with the correct definition for f of x for all real numbers, right? So if you think about it, f of x, if we define it like this, x squared for x greater than equal to 0 and minus x squared for x less than 0, then this function will satisfy both the conditions given in the first statement, right? F of x is odd now because x squared and minus x squared. So f of minus x is negative of f of x. Also, it is for x positive, it is x squared. So basically, we are using the first sentence to define the correct function here. And now we have to think about how to get the range of a, right? So let's try to use this condition, f of x plus a is greater than equal to twice of f of x. First of all, what is twice of f of x? Twice of f of x would be, for x positive, it would be 2x square, which can be written as root 2x whole square. So it can be written as f of root 2x for x positive, right? For x negative, it would be minus 2x square, which is basically negative of root 2x whole square, which is equal to f of root 2x if x is negative, right? Think about it. If x is negative, f of root 2x should be this, right? According to the definition, it will be minus of root 2x whole square, so minus 2x square. So in all the cases, we can say that f of 2x is equal to f of root 2x, right? Great. So if we understand that, then the inequality here becomes f of x plus a is greater than equal to f of root 2x, right? So we can write it like this, f of x plus a f of x plus a becomes greater than equal to f of root 2x, and this is true for all x belonging to a plus 2, right? Okay, so now let's think about when this inequality will be true. If you look at the graph of the function f of x is equal to x squared for positive and minus x squared for negative, you will realize that the graph is like this. And this graph is a function which is purely increasing. Throughout its domain, the function is always increasing, right? So if you take points like this, it's rising throughout, right? So that implies that if the function is an increasing function, f of x plus a is greater than equal to f of root 2x implies that x plus a is greater than equal to root 2x, right? And that just means that you have x 1 minus root 2 is greater than equal to minus a. And basically, we can say if you take the minus sign on this side and reverse the inequality, you will get a is greater than equal to root 2 minus 1 multiplied by x, right? This is the inequality that we get if we realize that the function is an increasing function. But this inequality is supposed to be true for all x lying in this domain, right? For all x lying between a to a plus 2, this inequality has to be true, right? So what is the maximum value of the left-hand side here? We can basically think that a should be greater than root 2 minus 1 into x, but x can go from a to a plus 2, right? So we can say a is greater than equal to root 2 minus 1 x, but x itself is greater than equal to, it can go up to a plus 2. So we can say greater than equal to root 2 minus 1 into a plus 2, right? So we are getting a is greater than equal to root 2 minus 1 a plus 2 root 2 minus 2, right? So if I bring everything on one side now, what I get is 0 is greater than equal to root 2 minus 2a plus 2 root 2 minus 2, right? And I'll bring everything on the other side now and basically solve for a, right? So let's see what comes. What we get is 2 minus 2 root 2 is greater than equal to root 2 minus 2a, and root 2 minus 2 is negative. So when we divide, we'll have to change the inequality. So 2 minus 2 root 2 by root 2 minus 2 is less than equal to a, right? And here, if I take root 2 common, I will get root 2 common, and inside the bracket, I will get root 2 minus 2. Root 2 minus 2. And that can cancel the factor here. And therefore, we get a is greater than equal to root 2, right? So, because we got this inequality at this stage, we are saying that since x can go up to a plus 2, the strict inequality will be if we take x is equal to a plus 2 here, and we should get a is greater than equal to this stuff, right? So that's how we solve this problem. The main thing here is to understand how to define the function f of x, and then realize that f of x is always an increasing function. So this inequality can be solved directly by saying x plus a should be greater than equal to root 2x, right? So I hope you understood the solution. The answer for it basically is root 2 to infinity, where a belongs to a is greater than root 2 throughout. Then this inequality, this condition will be satisfied. That's all for this video. I'll be live with more videos shortly. Please like and subscribe to the channel, and I'll see you in the next video.